Hello everyone, welcome back in Skolarhive. So this is the fifth video in our basic algebra series and the third part of polynomial. So the first two part of polynomial I discussed the basics, definitions and the remainder and factor theorem. So this video is completely based on problems based on the concept that we have learned in the lecture number 3 and 4. So in the last video, some of you commented that the division of polynomial is not clear. So this video, I'm going to start with the division of polynomial. So let me take an example. We have given x square plus x minus 1, which is going to be divided by x to the power 5 plus 3x cube minus 5x plus 7. So we have given the dividend as x to the power 4 plus 3x power 3 minus 5x plus 7, and the divisor is x square plus x minus 1. So we need to find the quotient as well as the remainder. So in order to find what is the quotient, we need to take over here. First thing is look for the leading term of the dividend and divide the leading term of this dividend by the leading term of the divisor. So we can find that the leading term of the dividend is x to the power 4 and the leading term of divisor is x square. So if we are dividing this leading term of dividend by the divisor, that is going to give us the leading terms of the quotient. So x to the power 4 divided by x square is x square. That will be the leading term of the quotient, which is x power 2. Now once we got this x square, now this x square is going to multiply it by this divisor, which is a trinomial quadratic. It means this x square is going to multiply with all of these three terms over here, and that we need to write down below this dividend. So once we multiply x square by x square, it is going to give us x to the power of 4. And then x square multiplied by x is x to the power of 3. So here this is plus, so plus plus plus. So x square into x is x to the power 3. Now next one is minus 1 times of x square. So minus 1 plus x square is minus x square. So that is going to be minus of x square. Now we need to subtract this. So what all expression we have written over here, in order to subtract this, what we need to do, we need to just revert the sign of this expression. So as x power 4 is plus, so that will be minus, and x cube is plus, that will be minus, x square is minus, that is going to be plus. Why we are doing that? So what we are doing, we are subtracting this one from this one. So let's try to understand this one. If we have given 4x power 4 plus 3x cube minus 5x plus 7, from this what we are subtracting? We are subtracting this expression, means minus sign, and the expression x to the power 4 plus x cube minus x square. If you simplify this, you will find that minus plus minus, minus plus minus, and minus minus plus, the sign of this term is going to be changed, and the sign of this term is not gonna impact anywhere, right? So this is basically what? Negative x to the power 4, negative x cube and plus x square, and this expression is as it is, x power 4 plus 3x power 3 minus 5x plus 7, right? So in a long division meter, when we are performing the division, make sure to revert the sign of the expression that we are getting upon multiplication of divisor with the quotient that we have gotten over there. Now this is plus x power 4, this is minus x power 4, this is gonna cancel. And over here the term 3x power 3 is in plus, and this x power 3 is in minus. So 3x power 3 minus x power 3 is going to be 2x to the power 3. And we don't have any x square term over here, and this is plus x square. So only plus x square, and now we can copy this minus 5x plus 7. So this is the first step, and in order to check, whenever we should have to continue until unless the remainder is going to be, the degree of the remainder is going to be lesser than the degree of this divisor. So as the degree of the divisor is 2, and the degree of the remainder is what? 3. So the further division is possible. So we'll follow the same procedure. Look for the leading coefficient, leading terms of this. Now this is the dividend, this is the divisor. The leading term is 2x power 3 and the leading term is x power 2. So we need to divide leading term of the dividend with the leading term of divisor. So once we divide 2x power 3 by x power 2, that is going to give us 2x. So the next terms in the quotient will be what? Plus 2x. So plus 2x cube over x square is what? Plus 2x. So the next term in the quotient is what? 2x. Now this 2x is going to multiply with whole term and we'll write on below this one. So 2x into x square is 2x power 3. And then plus x into 2x is what? 2x square, and minus plus minus 1 into 2x is 2x. Now change the sign of this expression. This 2x cube is in plus goes to minus, this plus goes to minus, minus goes to plus. And now cancel both of this. Plus 2x cube minus 2x cube got cancelled. Now this is plus x square, this is minus 2x square. So minus 2x square plus x square is what? Minus x square. And this is minus 5x, this is plus 2x. So minus 5 plus 2 is what? Minus 3x. And the constant we just have to copy. Now we can find that the remainder is this one. Still the degree of remainder is 2, which is equal to the degree of the divisor. So we need to further divide this one. So now the leading term of the remainder dividend is what? Negative x square, and over here divisor is x square. So we need to divide negative x square with x square. So negative x square, if we are dividing by x square, that is going to give us negative 1. So next term in the quotient is what? Negative 1. And this negative 1 is going to now multiply with each term over here. So once we multiply this, x square into minus 1 is minus x square, plus x into minus 1 is minus x, and minus 1 into minus 1 is what? Plus 1. Now just change the sign over here. This minus 2 plus, and plus 2 minus. So we can find that this negative x square and plus x square is going to be cancelled. This negative 3x plus x is what? Negative 2x, and 7 minus 1 is what? Plus 6. So over here we can find that the degree of the remainder is less than the degree of the divisor. So we cannot further simplify. We cannot further divide. So remainder that we got over here is, remainder is equal to negative 2x plus 6, and quotient is equal to what? X square plus 2x minus 1. So this is the way we are performing the long divisions of two polynomials. So let's take a few examples for the practice. I'm just writing down the question for you to practice. Okay, so the first question for you all to do yourself is, first one is x square minus x plus 3, and we are having 2x power 4 minus x cube plus 5. Find divisor, quotient and remainder when 2x power 4 minus x cube plus 5 is divided by x square minus x plus 3. Take the second example as x cube minus x plus 7 when this is going to divide x to the power 5 plus 4x cube minus 7x square plus 3. We need to find the quotient as well as the remainder. So our next question is, what must be added to a polynomial x cube plus x square minus 22x plus 90 so that it is completely divisible by completely divisible by x square minus x plus 7. So the question is, what must be added in this polynomial, which is a cubic polynomial, so that it is going to be completely divisible by this quadratic polynomial? So it means this polynomial, cubic polynomial, is not completely divisible by this quadratic polynomials. So we need to add something in this so that it must be divisible by this quadratic. So how we can solve this question? So let's try to go with the division of this cubic polynomial with this quadratic and see what we are getting as a remainder or quotient. So as we have given x cube plus x square minus 22x plus 19, when we divide it by x square minus x plus 7, so we'll find that leading term over here in the dividend is x cube and over here is x square. So once we divide x cube by x square, it will come x. So this x is going to multiply with all of this term over here, that will give us x cube minus x square plus 7x. Now subtract this, just revert the sign of each term written in the downward sides. So we'll get this as, over here this is going to be x cube cancelled, so x square is 2x square, and this is negative 29x plus 19. Now the degree of this remainder and the divisor path are same, so we need to go for one more step so that the degree of remainder should be less than the divisor. So over here this is 2x square and x square, so plus 2x square divided by x square is what? Plus 2. So plus 2 multiplied by this is 2x square minus 2x plus 14. So change the sign, we'll get this got cancelled, so 29 minus 2. So negative 29 plus 2 is what? Negative 27 x, and over here 19 minus 14 is plus 5. So we are getting the remainder as this one. So if we are having something like just negative of this thing in the dividend, then this might not come. So if we just look into this one with the help of the division algorithm, what it says that dividend is equal to divisor into quotient plus remainder. So if I'm trying to write this one, x cube plus x square minus 22x plus 19, which is dividend, is equal to divisor into quotient x square minus x plus 7 times of x plus 2, and the remainder is what? Negative 20x 7x plus 5. So we found that when we are dividing with this one, then we are getting the remainder this one, means this is not completely divisible, right? If you would have added this number, negative of this, in this dividend, then we might get this as completely divisible, right? So if we would have added negative of this number, means negative of the remainder, then this will be completely divisible, right? Why we can't say that? Why we can say? Just try to think of, okay, if we are adding both sides, just negative of this, try to do it x cube plus x square, negative 22x plus 19, and I'm doing addition of what? Addition of what? The remainder that we have gotten. So just add the remainder. What remainder we have gotten? Negative 27x plus 5. If I'm adding this number on either side, then this, I mean, we just have to add the whatever remainder we are getting, just negative of that. So negative of this is what? Plus 27 minus 5 on both sides. Then you will get as on the right side x square minus x plus 7 times of x plus 2 minus 27x plus 5, and we are adding what? We added negative of this on either side. So if I'm adding this 27x minus 5 over here, so this will be cancelled, right? This will be cancelled. Now we got this, the cubic polynomials, in that when we are adding this number, then we'll get there is no remainder. The divisor is this one, and the quotient is what? X plus 2. The remainder is 0. It means what expression we have added in this given cubic polynomial? The negative of the remainder that we are getting over here. What remainder we have gotten? We have gotten negative 27x plus 5. So in order to make this dividend completely divided by this divisor, we must have to just add the negative of the remainder. So this, I have used this long division to get the remainder, and then over here I have used the division algorithm. What it says that divisor is equal to quotient, dividend is equal to what? Dividend is equal to divisor into quotient plus remainder, and the degree of remainder is less than degree of divisor. This is what we have learned in the division algorithm, right? We can solve this without even finding this long division method. We can directly look into this division algorithm. So I'll let you know with another example how we can do this. So these things need to remember. Dividend is equal to divisor times quotient plus remainder, where the degree of the remainder will be less than the degree of the divisor. This is very important result. Most of the questions that we are gonna do will depend on this result, division algorithm. Okay, so let's see another example. So for this question, the answer is, what must be added to is nothing but negative of what we have added, negative 27x. In that, what we have added, we have added this one, 27x minus 5. So 27x minus 5 is the required expression which is needed to add in this cubic polynomial to make it completely divisible by x square minus x plus 7. Let's take another example. Suppose we have given what must be added to 3x square, 3x cube plus x square minus 22x plus 9, so that it is completely divisible by 3x square plus 7x minus 6. So we have given this cubic polynomial and we are trying to divide it by this quadratic. In that, we have to find what number need to be added in this so that it will be completely divisible. Means when we are dividing this cubic by this one, it is not going to be completely divisible. We will get some of the remainder, right? So what is need to be added in this dividend so that it will be completely divisible? So you can do it by long division method. You can do this by long division method and you can find the remainder. So in order to find what is need to be added, so whatever be the remainder we are getting, we just have to add the negative of that. If suppose we are getting the remainder as x minus 2, then we have to add the just negative of that, means negative of x minus 2. But this example I'm just going with the direct division algorithm. So what we have 3x cube plus x square minus 22x plus 9. So division algorithm, what it says that dividend is equal to divisor times of quotient plus remainder. Divisor times of quotient plus remainder, where what degree of remainder is lesser than the degree of dividend, degree of divisor. So over here, this is the dividend, which is equal to divisor is what? 3x square plus 7x minus 6. So 3x square minus plus 7x minus 6. Now we need to look for the divisor. So look into the leading term. This is 3x cube and this is 3x square. So what is need to be multiplied in this so that we can get this as 3x cube? Already we have 3x square, means we need to multiply this by x. So once we multiply this by x, this will come as 3x cube. Okay. Now next thing is we have over here plus x square. But if we see over here, the second term is x and this is the first term as x. So 7x into x is what? 7x square. 7x into x is 7x square, and when we are taking something over here, x is there, means surely next number will be constant, right? So what number need to take over here, so that by adding this 7x square and this number upon multiplication with the constant, the result should be plus x square. Means over here this is 7x into x means 7x square. So to make it plus x square we need minus 6. So over here 3x square is there, right? So if we are taking minus 2, then this is going to give us what? Plus x square. See, 7x into x is 7x square, then minus 2 into 3x square is what? Minus 6 square. So 7x square minus 6 square is what? Plus x square. Okay. Now the next one is, by doing this we have gotten this quotient. But over here you can be notice that now when we multiply this 7x by 2, that will give us the term containing x. The same way when we multiply this 6 by x, that will give us term containing x, as well as when we multiply this constant with constant, that will give the constant term. So we have further more terms hidden over here. So that is nothing but plus 7x into 2 is minus 14x is also there, and minus 6 into x is minus 6x, means we have negative 20x. We have negative 20x over here, and plus 6 minus 6 minus 6 minus 2 is what? Plus 12, means we have negative 20x plus 12, right? So once we multiply this, what we'll get? We'll get this as what I said, once we multiply with this, we'll get 3x cube plus x square minus 20x plus 12. But we want this equal to be what? Negative 22x plus 9. So to make this negative 22x, what is need to be added? So we need to add over here additionally negative 2x. Then this will become negative 20x minus of 2x is negative 22x. And over here we need plus 9, but we have plus 12, right? So we need to subtract 3. So that now this and this are both are equal. So over here we can find that, okay, upon dividing this cubic polynomial 3x cube plus x square minus 22x plus 9 by this 3x square plus 7x minus 6, we'll get this as a quotient. And the remainder is this one. This is the remainder. This is the remainder. But in the question we need to find what must be added to. What must be added to and this, so that this is what? Completely divisible. So the required number which is need to be added in this polynomial is what? The negative of the remainder. We are getting the remainder as remainder is equal to what? Negative 2x minus 3. So the required number need to add is what? Required number need to add is equal to just negative of this. Negative 2x minus 3 is what? Negative of this is what? Just see, negative 2x minus 3. So negative positive, negative positive. So 2x plus 3. This is the required number which is need to be added in the given dividend, so that it will be completely divisible by this given divisor 3x square plus 7x minus of 6. So we can solve this by long division as well, but I'll suggest you to practice some of the questions with this method directly. Like instead of going for long division, you can look for whatever be the number we have given, and we need to look for the quotient, right? By equating the leading term and the next term and then the next term, right? And whatever additional things we are getting, we need to balance both left and right of the equation by adding or subtracting the required expression. Now let's see one more example based on the same type of question. This time instead of adding, we need to subtract. What must be subtracted? What must be subtracted? What must be subtracted? What must be subtracted from the polynomial is given as x cubed negative 6x square negative 15x plus 8 plus let's say 80, so that it is completely divisible by x square plus x and minus 12. So what must be subtracted from this cubic polynomial x cubed negative 6x square negative 15x plus 80, so that it is completely divisible by this quantity? So you can go for both of the method. long division as well as the method I explained in the last example. Just try to write this with the help of division algorithm. This dividend is equal to divisor into quotient plus remainder. So I'm writing this as x cube negative 6x square negative 15x plus 80 is equal to divisor is x square plus x minus 12. Now we need to look for the leading term over here, x cube, and over here is x square. So what is need to multiply in this so that it will become x cube? So the thing is nothing but x only. X square into x is x cube. Now x cube term is over. Move for x square term. We need negative 6x square. We need negative 6x square. Over here x into x is x square and this term is x square. So obviously this is linear. So next term will be constant. So that we need to choose that constant in such a way that that constant with this 7, I mean this x square and this x into x, upon solving this should come negative 6 square. Negative 6x square. So over here x into x is x square. So we need negative 6x square means we need what? We have plus x square. To make it negative 6x square we need negative 7x square. So we need to take negative 7 over here. So that way we found the quotient. But we don't know what the remainder will come. These two both sides should be equal, right? So now check, this x is going to multiply it with 7. So that is going to give us negative 7x and this is negative 12x. So we'll get negative 19x over here. What we'll get? Once we simplify further, this will give us what? Negative 19x. But here on the left we have negative 15x. To make this negative 19 to negative 15x, we need to add 4x. So that negative 15 plus 4 is negative 19 plus 4 is what? Negative 15. Okay. Next one is constant term. Negative 12 into 7 is negative is what? Positive. 7 times of 12 is 84. But we need 80 only. We are getting plus 84, but we required plus 80. So we need to subtract 4. Now this is going to be left and right both are same. Left and right both are same. It means once we divide this cubic polynomial with this quadratic, so this is the divisor, this is the quotient, and this is the remainder. So we have gotten the remainder over here as 4x minus 4. As 4x minus 4. Now the question is, what is to be subtracted from the given polynomial? So what is need to be subtracted? So whatever be the remainder we are getting, that need to be subtracted. Then only this will be completely divisible by the x square plus x minus 12. Just think of, okay, if I'm subtracting both sides, negative 4x minus 4 on either side, the right side this term will become 0. It means on the right side divisor is this one, this is the quotient, and remainder is 0. Means if that part 4x minus 4 is subtracted from the given polynomial, means it will be completely divisible. So required number is what? Required expression or polynomial is equal to what? 4x minus 4, which need to be subtracted. So in the case of subtracted, means we need to just subtract whatever be the remainder we are getting. But if in question it is asked to write what must be added, what must be added, so in that case we need to like add the negative of the remainder that we are getting. Whatever be the remainder we are getting, the negative of that remainder we need to add in the given polynomial so that it will be completely divisible by the x square plus x minus 12. Okay. So this type of questions are easy. Once you practice, means it is very helpful in dealing with the polynomials, or you can try a few example based on the long division method and as well as this like analytical method, so that your thinking power will increase. Okay. Alhamdulillah. Now next question is, if x square minus x minus 1 is equal to 0, then find the value of x cube minus 2x plus 1. Then find the value of x cube minus 2x plus 1. Here we have given that the condition is x is positive. X is positive real number. So this is a very interesting question. So we have given this x square minus x minus 1 value as 0. We need to find this value. In fact, we might have given, instead of this, let's say this is the first part. The second part is, let's say we have given x to the power 12 minus x to the power 6 plus some number, let's say plus 5 is equal to what. So these two questions given. We need to find this values of these two when the given condition is x square minus x minus 1 is equal to 0. So let me just start with this given condition. So x square minus x minus 1 is equal to 0. So we can write this as x square is equal to 1 plus or x plus 1. X plus 1. X plus 1. I'm trying to solve the first one. So x square we have got is equal to x plus 1. We want x power 3. What we want over here? X power 3. So what we'll do is we'll try to multiply both sides of this equation by x. So this is, mark it as equation number 1. If I'm multiplying both sides of this equation by x, so the left side will become x power 2 times of x is x power 3, and right side will become x times of x plus 1. So if we distribute this, this will become x square plus x. So x cube is equal to what? X square plus x. And we have gotten this x square is equal to x plus 1 in equation number 1. So substitute back the value of x square as x plus 1. Then this will become x cube is equal to 2x plus 1. X cube is equal to what? 2x plus 1. So we have got the value of x cube is equal to 2x plus 1. Here we need to find x cube minus 2x plus 1. So if you see, can we take this 2x to the left by transposition? So by doing so, we'll get this as x cube. This switch to the left goes to minus 2x, and on the right we have 1. Okay, we have gotten the value of x cube minus 2x, but we want the value of x cube minus 2x plus 1. So if we are adding both sides 1, then we'll get the left side as x cube minus 2x plus 1 is equal to what? 1 plus 1. And 1 plus 1 is what? 2. So the answer for this question is 2. So one thing that you might have noticed, that what I have done is I reduced this x square in terms of x, and furthermore I reduced this x cube also in terms of linear. Even though if we are going for the 4th order or 5th order or whatever be, we can reduce those order in terms of order 1 in the variable. This method of reducing that we call as method of reduction. Method of reduction, which is like most of the time used in solving questions in like polynomials of the given conditions, and we need to find the values of the polynomial. Now see the second question. This is the first question. For that we have gotten the value as 2. Okay, so let's mark this x square as x plus 1. So we have gotten x cube is equal to 2x plus 1. So this one, take it as equation number 2. Now if again we are multiplying this by x, so that will left side will become x power 4, and right side will become 2x into x is 2x square plus x times of 1 is x. Now again substitute the value of x from first one over here. We'll get this as 2 times of x square as x plus 1. So x plus 1 plus x, which is 2x plus x is 3x, and this plus 2. So x power 4 is what? X power 4 is 2x plus 3x plus 2. So again we can multiply we can get the power 5, we need the power 12. So we can continue like this. Okay, we can continue like this. When we multiply next x on either side, the left side will become x power 5 and the right side will become 3x square plus 2x. So when we multiply this 2x plus 3x plus 2 with x, this 3x into x is 3x square and this 2 into x is 2x. Again substitute in place of x square as x plus 1. So this will become what? Then 3 times of x. If I'm substituting this 3x square, x square is x plus 1. So 3 times of x and 2 times of x is what? 5 times of x plus 3 times of 1 is 3. So x power 5 is equal to what? This one, 5x plus 3. Now we can find x power 6 by multiplying both sides by x. So the right side will become 5x square plus 3x. Now substitute the value of x plus x square as x plus 1. So this will become 5x plus 3x means 8x and 5 times of 1 is plus 5. So this is x power 6. X power 6. We got the value of x power 6, but we need the value of x to the power of 12. So why can't, like, we can directly take a square on either side of this, because 6 we have gotten, right? So x power 6 to the power 2 is what? We can use the power law, right? 6 times of 2 is 12. So what we can do in this step, as x to power 6 is equal to 8x plus 5 we have. Why can't we go for taking a square on either side? If I'm doing this, what we'll get? Left side x to power 6 power 2 means what? 6 times of 2 is x to the power 12. And right side we can use the a plus b whole square identity. So 8x square means 64x square plus 5 square means 25 plus 2ab means 2 into 8 into 5, 80x. So what we have got? We have got this as 8x square means 64x square, 5 square 25, 2 into 5 10 into 8 is 80x. Okay. Now x square over here, so we can substitute in place of x square as x plus 1. So that will give us 64x plus 80x. So 144x. And 64 into 1 is 64 plus 25. 64 plus 25 is what? 989. So this is the value of x to the power 12. Okay, so we have gotten the value of x to power 6, we have got the value of x to power 12, we need the value for this one. We need the value for x to the power of 12 minus x to power 6 plus 5. So let's try to substitute this value. What will get? X to the power 12 minus x to the power 6 is equal to 144x plus 5 also. Plus 5. So in place of x to power 12 we have 144x plus 89 minus x power 6 is 8x plus 5 means minus of 8x plus 5 and then we have plus 5. So we'll get this as 144x plus 89 minus 8x minus 5 plus 5 got cancelled. So we left with this as 136x plus 89. So we got the value of x to the power 12 minus x to the power 6 plus 5 is equal to 136 plus 89. Means we need the value of x. We need the value of x. So how we can find the value of x? We have given this quadratic. So you know how we can solve the quadratic equations? You can go for the quadratic formula, right? So what quadratic formula says that if we have given quadratic equation as ax square plus bx plus c is equal to 0, then x is equal to negative b plus minus root of b square minus 4ac by 2a. So we have given this equation x square minus x minus 1. So over here b is what? Negative 1. So we can find this x is equal to negative of negative 1 plus minus root of b square. B square what? Coefficient is negative 1, right? So negative 1 square minus 4 times of 1 over here, right? And the constant is negative 1. Divide by 2 into 1 is 2. So we get this as negative 1 into 1, negative 1 is plus 1 plus minus of 1 square means 1 and minus minus plus. 4/2. So over here, this means x is equal to 1 plus minus root 5/2. Root 5/2. As here we can find, as already in the question it is given, x is positive. So this plus minus 5 root 5 means what? One time we have to take plus, one time we need to take minus. So if we are taking minus over here, means 1 minus root 5/2. So root 5 is what? Bigger than root 4. Root 4 value is 2. So 1 minus 2 is negative. So 1 minus root 5 is also negative. So this number is what? Negative. So we should not take the value of x to be equal to 1 minus root 5/2. So what value we need to take? We need to take x is equal to 1 plus root 5/2. So this value of x we need to substitute over here. That is going to give us the values of this x to the power 12 minus x to the power 6 plus 5. So substitute this value of x over here. We'll get this as 136 times of x. Means this x is 1 plus root 5/2. So this 2 is going to cancel 136 as 6 and 8. 68 times of 1 plus root 5 plus 89. Plus 89. So once you simplify this, see, if you substitute the value of x to be 1 plus root 5/2 over here, so this 136 is multiplied with this. So 2 is going to cancel this 136 as 2 6 are 12 and then 2 8 are 16. So 68 times of 1 plus root 5 plus 89. So furthermore you can distribute this. So 68 times 1 is 68 and 68 times root 5 is 68 root 5. So 68 plus 89. 68 plus 89 what will come? 8 9 is 17, remainder 1, 8 6 14, 1 is 15. So 157 plus 68 root 5 is the answer for this question. So over here we can just plug the value of x. 136 times of 1 plus root 5/2 plus 89. So this going to cancel this. So 68 times of 1 plus root 5 plus 89. Right. So the value of this is going to be equal to what? This value is equal to 68 plus 89. 157 plus 68 root 5. So this question is very interesting, right? So take a questions to try by yourself. So the third part you have to solve. Try yourself. We have given if x square minus x minus 1 is 0, then find the value of x to the power of 8 minus of 5x power 4 plus 3. What is the value of this one? When we have given x square minus x minus 1 is 0, then find the value of x power 8 minus 5x to the power 4 plus 3. Now let's take another example on finding the values of polynomial if we have given some condition with the help of reduction method. Suppose we have given x square plus 2x is equal to 5 and we need to find the value of x to the power of 4 plus 28x plus 5 plus 28x plus 5. So we have given this condition x square plus 2x is 5 and we need to find the value of x to the power 8 plus 28x plus 5 value. So such kind of question will solve with the help of method of reduction. What we'll do, we'll try to write x square in terms of x and then with the help of that we can further simplify the values for the given polynomial. So x square plus 2x is equal to 5. Can we write this as x square is equal to 5 minus 2x? This is the first equation. Now we want x to the power 4 plus 28x plus 5. So we got the value of x square. And we want value of x to the power 4 that can be obtained by taking a square on either side of this equation 1. So if you are taking a square on both sides, so x square of a square on left and right side 5 minus 2x whole power 2. That will give us left side as x to the power 4 and right side we can use the a minus b whole square identity. That will give us what? First number 5 square plus 2x whole square minus 2 times of 5 times of 2x. Once we simplify this, this will become 25 plus 4x square minus 20x. Minus 20x. Now here we got the value of x square. So from equation number 1, in place of x square we can write 5 minus 2x. Once we substitute that, this will become 25 plus 4 times of 2x minus 5 minus 2x. 5 minus 2x and then negative 20x. So let's try to simplify this. 25 plus 20 minus 8x minus 20x is the value of x to the power 4. So this will become 45 minus 28x, x to the power 4 is equal to 45 minus 28x. In most of the case, this question will give us a condition that will be no need of evaluating the value of x. That will come in the like required expression, as we want 28x over here. So you can find x to power 4 is equal to 45 minus 28x. If I'm taking this to the left, that will become x to the power 4 plus 28x is equal to 45. Now this is the value of this one. We want value of x to power 4 plus 28x plus 5. So by adding 5 on both side, what we'll get? Left side is x to power 4 plus 28x plus 5, which is equal to 50. So this way we can find the value of a given polynomials if we have given a quadratic. So we can convert the quadratic into linear and we can use this method for finding the values. Okay. You can give the try for this. If we have given x square minus of 5x plus 3 is 0, then find the value of x to the power 6 minus 3x to the power 5 plus 3. By using the reduction method, you need to find the value of this one. Here I am giving the condition that x is positive. Do by yourself. Do by yourself and comment down the answer for this question. Now let's move on to solving problem based on remainder theorems and factor theorem. So what exactly the remainder theorem says that if we have any polynomials, when we are dividing that polynomial by a linear factor x minus a, then the remainder will be the values of the polynomial at x is equal to a. For example, if I am taking what? A polynomial px, which I am dividing by any linear factor x minus a. Then the remainder will get quotient as well as remainder. Then the remainder is the values of this polynomial at x is equal to a. So for example, we have given a polynomial px is equal to x square plus 5x minus 3 and we divide it by a linear polynomial x minus of 2. When we are dividing this px by x minus 2, then the remainder is equal to the values of this polynomial at x is equal to 2. So once we plug the value x is equal to 2 in this given polynomial, that will give us the values of the remainder. So 2 power 2 plus 5 times of 2 minus 3, which is 4 plus 10 minus 3 is equal to 14 minus 3 is the 11, which is the remainder. You can verify it by using the long division as well. So we have given this x minus 1, x minus 2 and px is x square plus 5x minus 3. So divide the leading term by the leading term. X square divided by x is x, so x square minus 2x, change the sign, this is got cancelled, so 7x minus 3. So leading term is 7x and over here is x, so when 7x divided by x, that will give us plus 7, so 7 times of x is 7x minus 7 times of 2 is 14, so change the sign, so this got cancelled, 14 minus 3 is plus 11. So we need not to go through this long division, just we have to use this remainder theorem. Whatever be the linear factor we have given, with that linear factor we need to find the value of x by equating that equal to 0. Let's take another example. Suppose we have given a polynomial px is equal to 3 times of x to the power of 2 minus 2 times of x plus 7, and we are dividing it by 2 by 3x minus plus 4, and we want to know the remainder. So here we are dividing this px by this linear factor 2 by 3x plus 4, and we need to find the remainder. So this remainder, this linear factor is not written in this format x minus a. So what value of x we need to put in this, means what value of x we have to put in this polynomial, so that will give us the remainder. So what to do? We need to just equate the given linear factor and find the value of x from this, and that value of x we can substitute in the given polynomial. So we can find that once we solve this, 2 by 3x plus 4 is 0, we'll get the value of x. That value of x we can substitute in this polynomial. So over here we can find 2 by 3x is equal to negative 4. So x is equal to what? Negative 4 by 2 times of 3. This 3 denominator goes to multiplication, numerator goes to denominator. This got cancelled, so x value is negative 6. So the remainder is what? The value of this polynomial at x is equal to negative 6. So when we substitute the value of x negative 6 in this will become 3 times of negative 6 square, negative 2 times of negative 6 plus 7, which is 3 times of 36 minus 1 is plus 12 plus 7. So once we multiply, this will become 108 plus 12 plus 7, which will be 127. So these are the simple questions, but we just have to understand, like if we have any polynomial px, and we have given remainder. We have given what? Remainder. We have given what? Remainder. Let's say remainder is equal to 7 when divided by x plus 4. What does it mean? If we have given polynomial in x, given remainder is 7 when divided by x plus 4, it means when we are dividing polynomial by x plus 4, it means what? We are finding the remainder by equating this equal to 0. X is equal, x plus 4 is 0, means x value is negative 4, means at x negative 4 the value of the polynomial is what? 7. Means p negative 4 is indicating what? Remainder, which is given as 7. So this is very useful result that we are gonna solve question based on this result. Suppose we have given a polynomial px when divided by a linear factor x minus 1 gives remainder 2. Px when divided by x minus 2 gives remainder 2, and when it divided by x minus 2 it gives remainder 1. Then find the remainder when px is divided by x minus 1 times of x minus 2. So we have given px is a polynomial when divided by x minus 1 gives remainder 2, and the same polynomial when divided by x minus 2 it gives remainder 1. Then we need to find the remainder when the same polynomial px is divided by x minus 1 times of x minus 2. Here it is not mentioned what is the degree of the polynomial. Only information is it is divided by x minus 1, remainder 2, divided by x minus 2, remainder 1, and when divided by the same by x minus 2 times x minus 1, what will be the remainder. So in order to solve this kind of questions, we need to again recall our division algorithm. What it says that when a polynomial px is divided by any other polynomial, let's say this is px polynomial, suppose I'm dividing it by a polynomial ax, then we'll get the quotient as well as the remainder, right? So what it says that dividend is equal to divisor times quotient plus remainder, and one more thing, that the remainder degree should be lesser than the degree of the divisor. So remainder degree of remainder is less than degree of divisor. So we'll use this concept in solving this kind of question. So what polynomial we have? We have polynomial px. Now we are dividing it by x minus 1 times of x minus 2. Then what will be the remainder? So as we can find that this x minus 1, x minus 2 is nothing but a quadratic. Once you expand it, this product of these two linear factor will give you quadratic. So it means the divisor is what? Quadratic. Divisor is quadratic means the remainder degree will be lesser than this, means the degree of the remainder will be a linear or might be constant. So in order to solve this, what we'll do, we can use the division algorithm and we can write this px is equal to x minus 1 times of x minus 2. When we are dividing this px by this quadratic divisor, we'll get a quotient, some quotient plus remainder. That remainder will come as a linear factor, so we can write the standard form of linear polynomial ax plus b, right? So you can see that when we are dividing this polynomial by x minus 1 times of x minus 2, we'll get some quotient over here, right? This is the polynomial px, and we'll get the remainder which is a linear, because this is a quadratic, so remainder will be a linear. Now what is given when px is divided by x minus 1, it gives remainder 1. It means p1 is equal to 2. When we are equating this x is equal to 1, then at x1 the remainder of this p polynomial is what? Given 2. So p1 is the remainder, so p1 is 2. With the second one, when we are dividing by x minus 2, the remainder is what? 1. So we can write this as p2 is equal to 1. Means we have given the value of p1 2, means at x is equal to 1 it is 2, and at x is equal to 2 it is 1. Now substitute this value of x1 and x2 in this given polynomial, this equation number 1, and find the value of a and b. Once we are able to find the value of a and b, this is only the remainder then, right? So once we substitute the value of x1 in this polynomial, then this p1 is equal to, on the right, this is 1 minus 1, 0, 0 times of something, this whole things will become 0, and over here in place of x, when we substituted 1, means this is a times of 1 is a plus b, so p1 is equal to a plus b, and p1 is given what? 2, so a plus b is equal to 2. Mark it as equation number 2. Again substitute the value of x is equal to 2 in this polynomial, so that will give us what? p2 is equal to, when we are putting the value x2, then 2 minus 2 is 0, 0 times of things 0, over here in place of x is 2, so this is 2a plus b, so we are getting 2a plus b is equal to what? p2 value given 1, means this is equal to 1. Mark it as equation number 3. Now we got the two equation in like the variable a and b, and this can be easily solved, right? By using the both equation, you can find the value of a or b from the second equation and substitute in the third one. So we have, this is a pair of linear equation in two variables. We have different method of solving this, but for now just go through the substitution method, means find the value of one variable from first equation and substitute in the second equation. We'll make a video completely on the system of equations in this basic algebra series. So for the time being, just follow the substitution method. What we can do over here, from equation number 3, which is 2a plus b is equal to 1, so we can find the value of b, which is equal to, this 2a is in the left, transposing to the right, that will give us what? B is equal to 1 minus 2a. anything in the left, if we are transposing which is in plus in the left, transposing to right goes to minus, right? Now this value of b, if you are substituting in the second one, that will give us what? A plus, in place of b, 1 minus 2a, which is equal to what? 2. Now this is a linear equation in one variable. We need to just simplify this. A minus 2a is minus a, 2 goes to the right, so 2 minus 1, so minus a is equal to 1, means a is equal to minus 1. When a is minus 1, substitute in this, so minus 1 into 2 is minus 2, and this minus minus will become plus, so plus 2 plus 1 is 3, right? So we will get this as p is equal to 1 minus 2 times of minus 1, so b is equal to 1 plus 2, which is equal to 3. So we got the value of b as well as a. It means the remainder is what? A is negative 1, so remainder is equal to negative 1 times of x, means negative x, plus b, which is 3. So remainder is negative x plus 3. Right. So this kind of questions is very important, and this is very simple. Some of the question, if you practice, means it's easy and understandable, right? So now let's see another question. Suppose, I'm just changing this factor over here. Suppose when px is divided by x plus 4 gives remainder minus 1, and when it divided by 2x minus 1 it gives remainder 1. Then find the remainder when px is divided by x plus 4 times of 2x minus 1. So problem is same, just I change the value, so the method is also same. What is the divisor? Divisor is x plus 4 times of 2x minus 1. It's a quadratic, means remainder will be obviously a linear. So we can find that px is equal to x plus 4 times of 2x minus 1, means this is the divisor, means we'll get some quotient, let's say that is qx, and we'll get the remainder as this is a quadratic, so remainder will be a linear, so ax plus b. First thing is done. Okay, this is the equation number 1. Now what is given? When px is divided by x plus 4, it gives remainder minus 1. What it means? It means what? At x is equal to minus 4, find the value of x from here. X plus 4 is 0, means x is minus 4, means at x is equal to minus 4, the value of px is what? Minus 1. So p minus 4 is equal to minus 1. Now second, what we have given, when divided px by 2x minus 1, it gives remainder 1. It means we have to find the value of x from here. At what value of x? The remainder, like the value of x is what? X, 2x minus 1, 0, means x is 1 over 2. Means p 1 over 2 is what given? This is the remainder when px is divided by x minus 1 by 2. Okay, or 2x minus 1. So at this, the value of remainder is 1. You can understand this. When we are dividing px by 2x minus 1, means we are finding this value of x from here by equating it to 0. So it means x, 2x is equal to 1, x is equal to 1 by 2. So over here, one thing need to be understand, if we are dividing px by 2x minus 1, or you can say from here x minus 1 by 2. This 2x minus 1 or x minus 1 by 2, both are same divisor only. So the remainder will be what? P minus p1 over 2. p1 over 2 is given as 1. Okay, so we got the value for the polynomial at x minus 4 and x is 1 by 2. So now we'll substitute the value of x minus 4 in this. So by doing so, what we'll get? Check it. So p minus 4 is equal to what? When we are putting minus 4 over here, minus 4 plus 4, 0. 0 times of this whole things will become 0. Means this one is minus 4a plus b. Minus 4a plus b, which is given as minus 1. Equation number 2. Now substitute x is equal to 1 by 2. So p 1 by 2 is equal to what? Substituting 1 by 2 means 2 times of 1 by 2 means 1. 1 minus 1 is 0. This whole thing is 0. So this is what? 1 by 2 times of a plus b, which is equal to 1. This is equation number 3. Now we got two equation in two variables, so we need to solve it. So by using substitution method, we can find the value of a or b from first, and we'll substitute in second, from second to first. So let's say the value of a from, or I'm finding the value of b from third equation. B is equal to what? B is equal to 1 minus of a by 2. This plus 1 by 2 a I'm transposing to the right, that will goes to minus a by 2. So this value I'm substituting in the second equation. So minus 4a, in place of b we have 1 minus a by 2, 1 minus a by 2, which is equal to minus 1. So now this is equation in one variable, so we can find the value of a. So negative 4a minus a by 2, transpose this 1 to that side, that will become minus 1 minus 1. So this is minus 8a minus a is equal to minus 2. So minus 9a is equal to minus 4. So a is equal to 4 over 9. So a value is 4 over 9. Then what will be the value of b? Substitute in this equation. So b is equal to 1 minus of a, which is 4 by 9. So 4 by 9 over 2. Means this 2 will cancel 4 2 times. So this is 2 by 9. So b is equal to 1 minus 2 by 9. So 9 minus 2. 9 minus 2 is what? 7 by 9. So this is the value of b. So we got the value of a and b. It means the remainder ax plus b is what? 4 by 9 times of x plus 7 by 9. Okay, I hope this is clear. So I'm just giving you one or two questions for practice. So try to solve the questions and comment on your answer. So let's take a question for your own practice. Do yourself. When px is divided by 4x minus 1, it gives remainder 2, and when it is divided by 2x plus 1, it gives remainder 1. Then find the remainder when px is divided by 4x minus 1 times of 2x plus 1. This is the first example, and the second problem is px, the same problem. When px is divided by, just write down, when px is divided by let's say x plus 1 by 2, when divided by x plus 1 by 2 gives remainder minus 1 by 2, and when divided by 2x plus 1 gives remainder 2, gives remainder minus 2. Then find remainder when px is divided by x plus 1 by 2 times of 2x plus 1. So do yourself 1, and this is do yourself 2 for the problem based on the remainder theorems. So few more questions are there in remainder theorem. So but before discussing that, let's move to the factor theorem based question. Now let's move on to the problem based on the factor theorem. So before discussing the problem based on the factor theorem, let's try to understand what exactly the factor theorem says. That if a polynomial px, if px is divided by a factor x minus a, then the value of polynomial at x is equal to a will be 0. This is the first part of the factor theorem. If px is divided by x minus a, then value of the polynomial at a will be 0. And the second part is if pa is 0, then x minus a is factor of polynomial px. So So factor theorem having two parts. First condition is px is divided by x minus a, means the value of the polynomial at a is 0, means the remainder is 0, means it will be completely divisible. Px will be completely divisible by x minus a, then the remainder will be 0. And if the remainder is 0, when we are dividing any of the polynomial by any of the divisor, if the remainder is 0, means we'll call that divisor as a factor of the given polynomial. So this is what exactly the factor theorem is. Now let's try to solve question based on this. If f minus 2 by 5 is equal to 0, then for fx the factor is option A, x minus 2 by 5, option B, 5x plus 2, option C, negative 5x plus 2, option D is minus x plus 2 by 5. We have given value of polynomial f at negative 2 by 5 is 0, then for fx, which one is the factor? Now using the factor theorem, what we said, if a polynomial value at a is 0, then x minus a is factor. So with this we can say that if minus 2 by 5 0, it means if minus 2 by 5 0 is 0, means x minus 2 by 5 is factor. So here this x minus plus 2 by 5 is factor, but this is not in the option, right? If x plus 2 by 5 is factor, then by taking 1 by 5 common from this, we'll get it as 1 by 5 times of 5x plus 2 is also factor. If 1 by 5 times of 5x plus 2 is factor, so we can say that 5x plus 2 is also factor. So option number B is correct. Now let's take another example. If x minus 2 is common factor of polynomial px is equal to x cube minus 2x square plus ax plus b, and qx is equal to x cube minus ax square plus bx plus 8. Then find the value of 3a square minus 2b. Here we have given x minus 2 is common factor of this polynomial px as well as qx. So as x minus 2 is factor of px, means at x is equal to 2, polynomial p value will be 0, as well as at x is equal to 2, polynomial q value also will be equal to 0. So we can write this p2 is equal to 2 power 3 minus 2 times of 2 power 2 plus 2 times of a plus b, which is equal to 0. So once we simplify this, we can get this as 2 power 3 is 8 minus 2 power 2 is 4 times of 2 is 8. Means this part got cancelled, so we left with only 2a plus b is equal to 0. This is equation number 1. See, once you simplify this, you'll get this value as 8, and over here 2 power 2 is 4, 4 times of 2 is 8, so this both got cancelled. Now we have given this qx is x cube minus ax square. So q2 is equal to 2 power 3 minus of a times of 2 power 2 plus b times of 2 plus 8 is equal to 0. Now over here this 2 power 3 is 8 and this 8, both are in plus, so 8 plus 8 is 16 and 2 power 2 is 4. So this is negative 4a plus 2b plus 16 is equal to 0. Now here we can find in all of this term 2 is common, so we can take 2 common. We'll get this as negative 2a plus b plus 8 by taking 2 common from all of this term. So as 2 is not 0, the product of two number is 0 only if either this number zeros or this number zeros, right? So 2 is not 0 means this expression need to be 0. So 2a plus b plus 8 is 0. So now minus 2a plus b is equal to minus 8. So again we got another equation. So the two equation in two variable a and b. So we can solve this by finding the value of one variable in terms of other. So from equation number 1 we can get the value of b is equal to negative 2a. So once we solve this, we'll get b is equal to negative 2a, because 2a is in plus. If we are shifting to the right, it will go minus 2 minus 0 minus 2a is minus 2a. So this value of b we need to use in the second equation. So this is minus 2a, in place of b we got minus 2a. So plus minus 2a is equal to minus 8. So minus 2a is minus 4a is equal to minus 8. So a is equal to 2. So the value of a is 2. Once we substitute the value of a in this, we'll get the value of b to be equal to minus 4. b is equal to minus 4. So we got the value of a and b. So the value of this expression 3a square minus 2b is equal to what? 3 times of 2 square minus 2 times of minus 4, which is equal to 2 to the 2 power 2 means 4, 4 3 the 12, and minus minus plus 4 to the 8 means equal to 20. So the answer for the question that the value of 3a square minus 2b is 20, where x minus 2 is factor of this common factor for both of the polynomial. So this kind of questions need to be practiced to master this all kind of basics of this factor theorems and remainder theorem. Now let's take one more examples based on the factor theorem. This question is for do by yourself. Do by yourself. If 2x plus 1 is common factor of px, which is equal to x power 4 minus of lambda times of x square plus 3x minus 4, and qx is given as xq. Over here lambda, let me just keep the value as simple, let's say a, and this is b, and xq minus 5x square plus 3ax plus 2b. Then find the value of a square by 2 minus b. A square by 2 minus b. So this question is for you all for practice. We have given this common factor for this two given polynomial in which the unknowns are a and b. So by evaluating the value of a and b, we can plug in this to get the required values. Okay, so now this is the last question for this video. Suppose a, b, c are distinct real numbers. If a, b, c are real numbers, and when px divided by x minus a, x minus b and x minus c, it gives remainder a comma b and c respectively. Find the remainder when px is divided by x minus a times x minus b times x minus c. So over here we can find that as, so if we multiply over here x with x, that will give us x square, and again with x means x cube. So divisor is a cubic polynomial. So once we divide any polynomial by a cubic polynomials, then the degree of the remainder will be either quadratic, linear or constant. I mean the degree of the remainder should be lesser than the degree of the divisor. So over here this is the divisor. So we can write with the help of division algorithm, the polynomial px is equal to x minus a times x minus b times x minus c, and we'll get some quotient, okay, plus as this is cubic, so remainder will be a quadratic. So you already know the standard form of quadratic is ax square plus bx plus c, right? But as in this question we have given a, b, c, so we should avoid using this a, b, c. Instead of that, using a, b, c, we can use any other variable. Let's say px square plus qx plus r, where p, q and r are the real number, might be p 0 or not 0 depending on the problem. If p0 means this will be linear, if p not 0 means quadratic, right? Now as in the given question, when px is divided by x minus a, remainder is a, when divided by x minus b, remainder is b, and when divided by x minus c, remainder is c. So we can write that with the help of remainder theorem, that at x is equal to a, the remainder is a, means pa is equal to a, and the same way pb is equal to b, and at x is equal to c, the remainder is c, right? So the value of polynomial at c is what? C. Okay. Now this is mark it as equation 1. What we'll do is we'll plug the value of x in this for all of this. For doing so we'll get 3 equations. So once we plug x is equal to a in this, we'll get that a minus a is 0, means this whole term will be 0. So we'll get this as p a square plus qa plus r. So we'll get this as p a square plus qa plus r is equal to a. This is equation number 2. And when we substitute x is equal to b, then b minus b is 0, means again this is going to be 0. So this will give us at x is equal to b, means p times of b square. So pb square and qb plus r is equal to b. And the same way, this is equation number 3. Same way, when we substitute c, then c minus c is 0, whole term 0, then this will be pc square plus qc plus r. So pc square plus qc plus r is equal to c. This is equation number 4. Now over here we got 3 equation in 3 variable p, q and r. We need to solve this equation for p, q and r. How we can solve? As one thing we need to be remembered, like when we have given a single equation in one variable, then we have a solution. But if we have given a single equation in 2 variables, then we will have infinite number of solution. But if we have a pair of equation in 2 variables, then we might have one solution, infinite solution, or no solution, right? So for solving exactly, for finding the one solution, then we need to look for the for 3 variable, we need 3 equations to get the values of all the 3 variables p and q and r. Okay, so how we can do this? So if we look into the 3 equation, we can find that the p, q and r are the 3 variables. Over here the coefficient of p are different in the 3 equation, and for q also the coefficient are different, but the coefficient of the r are same, so we can cancel this r easily. So what we'll do, we'll subtract these 2 equations. When we subtract 2 and 3, what we'll get? So p times of a square minus p times of b square, so we'll get this as pa square minus pb square plus q times of a minus q times of b, qa minus qb, and then r minus r plus r minus r, and on the right side a minus b, a minus b. So we can find that this r and r got cancelled, and in this pa square minus pb square, p is common. So this is pa square minus pb square, and in qa minus qb, q is common. So this is a minus p times q is equal to a minus b. Now the left side we can find p times of a square minus b square. This is an identity, like a square minus b square is equal to a plus b, a minus b. So we can find that this is actually a plus b times of a minus b, means this term having a minus b, this term also having a minus b, and on the right side also we have a minus b. So we can do one thing, we can take a minus b common. So first write it down to avoid the confusion. A plus b, a minus b plus q times of a minus b is equal to a minus b. Now by taking a minus b common, what will get? By taking a minus b common, this term will be p times of a plus b, and over here plus q is equal to a minus b. Now this a minus b goes to that side in division, so a minus b over a minus b is 1, or you can directly cancel over here, so 1 times. So on the right side we have 1, this is p times of a plus b plus q is equal to 1. So this is our equation in two variable p and q. So mark it as equation number 5. Now the same way, if we are solving these two equation, so we'll get p times of b square minus p times of c square, means p is common, b square minus c square, and q times of b minus c, r cancelled, b minus c. So once we do this, once we do 3 minus 4, what will get? P common, b square minus c square plus q common, b minus c is equal to b minus c. See, p b square minus pc square, p common means b square minus c square, qb minus qc, q common means b minus c, and r got cancelled, b minus c. So again with the same identity like we have done over here, this is b minus c common, so this is p times of b plus c plus q is equal to b minus c. We have taken b minus c common here, so this b minus c cancel, means p times of b plus c plus q is equal to 1. This is equation number 6. Now these are the two equations in two variable p and q, so we need to solve this two equation for p and q first. That we can do by the substitution method. Find the value of q from this one and substitute in this, or take the value of q from this and substitute in this. So let me take the value of p from, let's say, fifth equation. I'm taking the value of p, value of q, which is q is equal to what? 1 minus, this goes to that side, p times of a plus b, and this value I'm going to substitute in this equation. So this is what? In equation number 6 I'm substituting p times of b plus c, and in place of q, 1 minus of p times of a plus b is equal to 1. So once we simplify this, left side plus 1, right side plus 1 got cancelled, so we're left with 0 on the right, and this is p times of b plus p times of c minus p times of a minus p times of b is 0. So this got cancelled, we're left with p times of c minus a is 0. Now over here we have got this p times of c minus a is 0, means product of two number is 0. Product of two number is 0. Product of two number is 0, right? So product of two number is 0. So product of two number 0 means what? Either first one 0 or second one 0. So let's say if p 0, c minus a not 0, and the second case is p not 0, c minus a 0. Once we are taking c minus a 0 means c is equal to a. But in the question it is mentioned that a, b and c are distinct, so this is not going to be happen, right? So this is not going to happen. So what is going to happen? P is equal to 0. So we got the value of p, then p is equal to 0. Now once we got the value of p 0, then the value of q will be what? Q is equal to 1 minus p times of something. It means what? Q value is equal to 1. Q value is what? 1. Once we substitute the value of p, which we got 0, and q, which is 1 minus p times of a plus b, p is 0 means 0 times something is 0, so this is what? 1. So we got the value of p and q as 0 and 1, so we can find the value of r by substituting p and q in any one of these equations, either in this or this. So let me take the value of p and q in the second equation. When we are keeping the value of p to be 0, then this will be 0, q is 1, then this will become equal to, this will be equal to what? 0 times of a square means 0 plus q is 1 means 1 times of a is a plus r is equal to a, right? So see, what I'm doing is I'm just substituting the value of p, which is 0. So 0 times of a square, and the value of q is 1 times of a plus r is equal to a in this equation. So 0 times something is 0, and 1 times of A is A plus R is equal to A. So A plus R is equal to A means R is equal to what? A got cancelled. So when you are transposing to the right, that will give us what? R is equal to 0. So now we got the value of P, Q and R. P is 0, R is 0. So only the value of Q is 1. So the remainder will become what? This is the remainder, right? So remainder is equal to what? Q1, which is 1 times of X. So the remainder is X. This is very interesting questions. So which will make you to solve like multiple equations by solving first these two equations. Like we got 3 equations, from that we are solving first 2 pair, that is going to give us equation in 2 variables. Here A and B we are not treating as variable, the variable is P and Q over here, P, Q and R. Okay, so when we are solving this third and fourth, we are getting another equation which is over here. Now these 2 equations we got in P and Q, so we need to solve this for P and Q. So we can solve it by taking the values of Q from this equation and then substituting in the another one. So by doing so we got this thing, and this is also very important point over here, the product of P and C minus A. See here, PC minus PA, P taken common, so C minus A, P times of C minus A is 0. Now product of two numbers 0 means either first 0 or second 0. So first case I'm taking P is equal to 0, C minus A not 0. Okay, so second case I'm taking P is not 0, then C minus A should be 0. But if C minus A is 0 means what? C and A both should be equal. But in the question it is mentioned they are not equal. So the obvious value of P is 0. This value of P we substitute in Q, that give us the value of Q. And then these two value of P and Q we are substituting back in any one of this equation to find the value of R. So once we did this, we got the value of R, and those value of P, Q and R is substituting in the remainder that we have assumed. So we got the remainder as EX. I hope this is clear, right? So this is very interesting. So let me just end this video by giving you one question which is somehow similar to this one, right? Okay, so question for you is do yourself. Do yourself. The remainder when x to the power 5 plus k times x is divided by x minus 1 times x minus 2 times x minus 3 contains no terms in x square. Find value of k without long division, or using you can say that using division algorithm. And remainder theorem. Okay, so this is the question for this video, and this basic algebra part will continue. So this is the third video for the polynomial. So next video I'll make for the identities and then factorizations. After identities and factorizations, we'll solve some more questions based on remainder theorem and factor theorem, because this question needs the idea of factorization. So I'm not including those questions in this today's video. So once I'll discuss the identities and the factorization, then I'll take one more like problem solving videos for the remainder theorems and factor theorem. So stay connected and try to solve all the questions that I have given as do yourself, or practice those all questions. You write down the solution for those questions by giving the numbering question number 1 this answer, question number 2 this answer, and comment down in the comment sections. If you are unable to solve some of the questions, then you can directly text me on WhatsApp. I'll surely help there too as well. Okay, so stay connected. We'll meet soon in the next video.